Today we'll be starting a new chapter, that is logarithm. So indices and logarithm are always usually studied together because one is it's very useful in some extents, right? Now, when we talk about logarithm, the actual name is logarithmic function. Like function can be treated to some extent like an equation. You'll study function later on in your classes. So what happens is like you had x square, it's an equation. I give an input 2, in return it gives me an output 4. I give an input 3, in return it gives me an output 9. I give an input 4, it gives me in return an output 16, right? Similarly, like you had trigonometry. So if I give an input, say sine theta is the equation or the function. So if I give an input 30 degree, so sine 30 gives an output half. If I give an input 45 degree, it would give me in return sine 45 1 by root, right? So similarly, we have logarithmic function also. We'll be having log x. Now, there also has to be a base with it. It is read as log x base a. Log x base a. So, this equation will also have an answer b. So, if I put an input x, in return, I'll get an output y. If I give an input for x, in return, I'm going to get an answer. In return, I'm going to get an output, that is b. Remember that both x and a has to be positive. They have to be positive, right? So, from first of all, as I said, that indices and logarithm are always studied together. Why is that so? So, if I have a logarithmic term, I can transform it into an indices term. For example, if I have log x base a equal b, this is in logarithm. When I remove the logarithm, I can convert it into indices. How do I do that? The base of log is a. This a is the base. So what happened is the base of the logarithm moves and becomes the base of the exponent. So this a goes to that side and pushes b to the power. So when I remove logarithm, I'll have x equal a raised to the power b. For example, if I have log 25 base 5 equal to, if I want to remove the logarithm, what will I get?
25 is equal to 5 square.
Can't hear.
25 is equal to 5 square.
Rest of you. If I remove the logarithm and I want to write indices term, what will happen? 5 goes there. So
Yes, ma'am.
25 will become 5 power 2.
5 square. Yes.
So if I ask you 0.01 base 10 equal minus 2, remove the logarithm. Remove the logarithm, write the indices term, exponent term. What should I write?
0.01 equal to
Equal
1 by 10 power
It to
minus
the
2.
power
10 power
Minus 2.
minus 2. Clear?
Yes, ma'am.
Now we can have the other way around also. From indices, we can convert into logarithm. Right? So what will happen in that case? We will have an exponent term. I'll change it into a logarithmic term. For example, if I have 10 power 3 equal 100. So right now, the base of the exponent is 10. So what will happen is that 10 will go down and become the base of the logarithm and the power will now slide down. So I'll have 3 equal log 100 base 10. So if I have a power m equal n, change it into logarithm.
M is equals to log a by power to the n.
A goes there. So it will be n base a. Log n base a. Yes?
Yes, ma'am.
If I give you 4 power 3 equals 64. Write it in logarithm. What will we get?
3 equals 3 equals log 64 to the power 4.
64 base 4.
64 base 4.
Base 4.
4 goes down.
64 base 4.
Clear?
Yes, ma'am.
Everybody clear till here?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So the first thing that we learn in this particular topic is how to convert from logarithm to indices and indices to logarithm. Yes? So let us try. ML Agarwal, exercise 2.2, question number 1. Okay. So the first one asks only to convert it into logarithm. So Roman 1, 5 square equal 25. Answer.
2 equal to log 25 to the base 5.
Very good. Second, a power 5 equals 64. A goes down. So 5 equal log 64 base a. Third, 9 power 0 is 1. What should I write?
Log 1 to the base 9 is
To
equal to 0.
log 1 base 9.
Fourth, 3 power minus 2 is 1 by 9. So minus 2, 3 goes down. Log 1 by 9 base 3. The entire fraction is the top number. Yes?
Yes, ma'am.
Fifth question. 10 power minus 2 is 0.01. So if I take log here, 10 goes down. So minus 2 is log 0.01 base 10. Sixth, 81 to the power 3 upon 4 is 27. So this 81 goes down and 3 by 4 becomes the answer. So 3 by 4 is equal log 27 base 80. Any doubt?
No,
No,
ma'am.
ma'am.
No, ma'am. No.
Done?
Yes,
The
ma'am.
second one, where we have been given the logarithmic one, we have to change it into the indices one. So first one, log 32 base 2 equal 5. Converted into indices, 2 goes to the right hand side. So 32 is 2 raised to the power 5. Second one, log 1 by 3 base 3 minus 1. Answer please.
1 by 3 is equals to 3 to the power minus 1.
Perfect. Third, log 4 base 8 equal 2 by 3. Answer.
4 is equals to 8 to the power 2 by 3.
4 is 8 raised to the power 2 by 3. Number 4, log 0.001 base 10 is
10 power
minus.
minus 3 equal to 0.0.
Perfect. Fifth, log 0.25 base 2 equal minus 2. So remove the logarithm.
2 power minus 2 equal to 0.25.
Perfect. 0.25 is 2 raised power minus 2. And sixth one, log 1 upon a base a equal minus 1.
1 by a is equals to 1 minus 1 to the power minus a.
No?
Sir,
A
a
power
to the
minus 1
power
equal to
minus
1 by
1.
A
a.
A
to the power
quotient
of
a
minus
to
1
the
is
power
equal to 1
minus
by
2.
a.
Is it okay?
Yes, ma'am.
Now, in the same way, we can also do solving the linear equations, right? Again, revising it, we are doing logarithm and we did indices earlier. First, in logarithm, we have log x base a. Both of them have to be positive. Both x and a have to be positive, right? So if the answer is b, answer can be any real number, b can be any real number. If I remove this logarithm, a goes to the right side. So x is a raised to the power b. So we can convert a logarithmic expression into an indices expression. Or if I have 5 cube equal 125, this is an exponent. I can convert it into logarithm. This 5 goes down and it becomes 3 equal log 125 base 5. Any doubt?
No, ma'am.
No, ma'am.
No. Sometimes in our base, we don't write anything. For example, if I have only log 2 and I haven't written anything in the base, I haven't written anything in the base. See, this logarithm chapter in itself on 11 is important, but it is very important for the calculus portion. In 11, you have some portion. In 12, you have quite a long portion of logarithm. So we'll need logarithm in huge quantity when we do calculus portion, right? So when we are talking about the base, when nothing is mentioned, so right now when we are doing class 11 logarithm chapter, only logarithm chapter I'm saying, if nothing is written in the base, we take the base to be 10. We assume that they want us to take the base 10 only and only in class 11 logarithmic chapter, right? If nothing is written in the base, if nothing is written in base, then we take the base, to be 10, but only in logarithm chapter itself. Only in logarithm chapter itself. That means when we have logarithm in other chapters, for example, calculus, but when we encounter logarithm, in other chapters, like calculus, we take the base as e. See, in maths, you already have pi, a letter which has a very special importance in our history, right? What is pi? Pi is 22 by 7 or 3.14, right? Similar to that, we also have a letter E, which is exponential number. Exponential number. Similar to maths, if we have pi, right? We have already studied pi a lot of number of times. Similarly, we also have E. What is E? E is known as an exponential number and E has the value 2.71828 and so on. We'll never put the value just for knowledge purpose. The value of E is 2.71828. So if in logarithm, in other chapters, nothing is written in the base, we always assume that the base is E, fixed, always. Only in this particular chapter, when we are doing it for class 11, we take the base to be 10. Why? Because I later on explain it. The reason is we have a table and that table is expressed with base 10. That's why. I'll come to that again. So understood this part? If in other chapters you encounter log x and nothing is written in the base, you assume that the base is written to be e. In this particular chapter, if nothing is written in the base, you assume that the base is
10.
10. So the base 10 is known as common logarithm. Don't need the word as such, just for general knowledge. Common logarithm and base e is known as natural logarithm, just for knowledge purpose. Okay. So as I said, we can use the same logarithm to indices conversion to solve certain values, to solve certain equations or find certain values. How can I do that? Suppose the question is log x base 4 equal 3. And what I want to do is I want to find the value of x. So it becomes pretty simple when I convert this logarithmic equation into an exponential exponent equation. So if I remove logarithm, what will I get?
X is equal to 64.
Yes. So x will become 4 power 3. That is x is 64. Understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Right?
Yes, ma'am.
But if nothing is mentioned, for example, they only tell us that we need to find the value of 81 base 27. They just told us to find the value of this. So we have another way also later on. Right now, in comparison to the knowledge that we have, we'll assume this solution. We will assume this to be equal to x. And now let us try to solve this. So if I remove logarithm, 27 goes to the other end. So 81 is 27 raised to the power x. Now 81 can be written as
3
to the
power
power
4.
4.
and 27 can be written as 3 power 3.
3 cube. The whole
So
x.
3 and x gets cancelled. 3 and x gets multiplied. Now, since the bases are same, we can compare and say that since the bases are equal, the powers also have to be equal.
Yes,
So I
ma'am.
have 4 equal 3x. Shift this 3 on the left side, 4 by 3 will be x. In logarithm, we don't usually have, see, right now is the answer. So you can have positive, negative, anything. But in the previous question, I could have never had a negative answer because that is the input I would have given. Is it understood till here?
Yes,
Yes,
ma'am.
ma'am.
Yes. Yes, ma'am.
So let us try exercise 2.2, question number 3 and 4 with this method. Question number 3 and 4 using this method. P1. Log 16 base 2. Let us assume that this is equal to x. So if we remove the logarithm, what will we get?
16 is
16 is
equal
equal
to
to 2
2 to
power
the
x.
power 4.
2 power x.
So 16 can be written as 2 power
2 power
4.
4 equal to 2 power x. X is equal to 4.
Perfect. Perfect. Please try the other sums. Question number 2. Log 8 base 4 equal x. So 8 will be 4 goes to the other end. 4 power x. 4 become 2 cube. 4 is 2 square. Base are same, so the powers also have to be same. So 3 by 2 equal x. Is it okay?
Yes.
Is
Yes,
any of
yes,
the
ma'am.
student finding the class a little faster? Do you want me to slow down? Please let me know. Okay. Third, log 0.01 base 10 equal x. So 0.01 is 10 power x. So 1 upon, since there are two numbers after the decimal, there will be two zeros in the denominator. Now 100 can be written as 10 square. But on the right hand side, we have 10 in the numerator. I can't have on my left hand side 10 in the denominator. So if I bring 10 to the numerator, we had the formula that the power changes the sign when we move from one place to another. So minus 2. Base is same. So the answer will be x equal minus 2. Any doubt?
No, ma'am.
Vanilla, are you able to do the sums?
Yes, ma'am.
Fourth, log 1 by 7 base 7 equal x. So 7 goes to the other end. 1 by 7 equals 7 power x. 1 by 7 can be written as
7 to the power minus
very good. So base is same. So minus 1 equal x. Fifth question. Log 256.5. Let it be equal to x. Always right, Linka. So 256 will be 0.5 to the power x. 256 is 2 to the power 8, I guess.
Yes, ma'am.
0.5 is 5 by 10. 5 by 10, 10, if I cancel, it's 1 upon 2. So when it comes to the numerator, the power becomes negative. So base is same. So we can have 8 equal minus 6. That is, x will be minus 8. X will be negative 8. Any doubts?
No,
No.
ma'am.
Done?
Yes, ma'am.
Question number 4.
Yes.
So in this case, we don't need to take an assumption. It's already given. So from here, x will be 3 goes to the other end. 3 square, that is 9. X is 3 square 9. Second, log x base 10 equal minus 2. So x will be 10 to the power minus 2. 1 by 10 square, that is 1 upon 100. You can also express it in decimal 0.01 or you can leave it in the fraction also. Any which way you feel comfortable. Done, Talia?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Third, log 1 upon 4 base x equal minus 1. So 1 by 4, x goes to the other end, x power minus 1. Whenever we have a negative power, we bring it to the denominator or to the other one. Cross multiplication, x will be 4. Yes?
Yes, ma'am.
Continue.
Yes, ma'am.
Fourth question. Log x base 81 is 3 by 2. So x will be 81 to the power 3 by 2. 81 can be written as 3 power 4. 2 2s up. So this is 3 to the power 6, which is what's 3 power 6?
729.
Perfect. Does it match till here?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
Fifth
ma'am.
question. Any student is facing any problem with the sums?
No, ma'am.
No,
No,
ma'am.
ma'am.
No, ma'am.
Let me know. Huh? So log x base 4 equal minus 1.5. So x is 4 to the power minus 1.5. 4 can be written as 2 square. So 2 into minus 1.5 is minus 3. 2 power minus 3 goes to the denominator, becomes positive. So it is 1 upon 8. Answer is 1 upon 8. Clear?
Yes,
Yes,
Yes.
ma'am.
6. Log x plus 1 base root 3 equal to. So root 3 goes to the other end. X plus 1 can be written as root 3 square. So x plus 1 root 3 square is
3.
so x will be 3 minus 1 2. Number 7. Log 2x plus 3 base 4 equal 3 by 2. So 2x plus 3 equal 4 to the power 3 by 2. Now 4 can be written as 2 square. 2 gets cancelled. So 2x plus 3 equal to the power 3. 2x plus 3. 2 to the power 3 is 8. So from here, twice x will be 8 minus 3, 5. So x will be 5 by 2. Done?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
8 log x square minus 1 base 2 equal 3. So 2 goes to the other side. X square minus 1 is 2 power 3. X square minus 1 is 8. X square will be 8 plus 1, 9. So the answer of x will be
Plus or minus 3.
Plus or minus 3.
in this case, it can be plus minus 3. Understand one more thing. Huh? Suppose the question was somewhere like here I had x. And the same situation may have arisen and you would have gotten x square equal to 9. If the question would have been in this way, that x is only alone in the power, in the upper number, then I could not have written x equal to minus 3 as the answer. Because as I said earlier also, log x base a, both x and a have to be positive. Right now, this is x square. So whether I take 3 or I take minus 3, it doesn't matter. Right? So in this particular case, right now, the answer can be both plus minus 3. But if the question would have been only log x, and there would have been scenario like you are getting both 3 and minus 3 as the answer, you can't write minus 3. Is it clear?
Yes, ma'am.
On
Yes,
the left
ma'am.
hand side, log x base a, I'm saying, equal to, on the right hand side, you can have positive, negative, anything. But if it is log x base a, both x and a cannot be negative. So right now, we can have both positive and negative, x is plus minus 3. Clear?
Yes, ma'am.
Yes, ma'am.
9. Log x equal minus 1. Nothing is written in the base. That means
We have to assume this as 10.
base is 10. So now 10 goes to the other side. X is 10 power minus 1. So x will be 1 upon 10 or 0.1. Any doubt?
No, ma'am.
Mm.
Everybody understood?
Yes, ma'am. Yes, ma'am.
10. So there are 3 questions basically in one particular question. First, log x is minus 2. Nothing is written in the base, so the base will be 10. So x will be 10 to the power minus 2, 1 by 10 square, that is 1 by 100 or 0.01, 1 upon 100 or 0.01. Second one, if log value is 0, base is 10. So from here, what will we get?
X is equals to 10 to the power 0.
And anything to the power 0 is
1.
1.
very good. Third, log x equal 1 upon 3. So base is again 10. So x will be 10 to the power 1 by 3. We can leave here also. Or we can write cube root 10 also. Any which way. Any problem?
No, ma'am.
No, ma'am.
No,
All of you
ma'am.
clear till here?
Yes, ma'am.
Yes.
Yes, ma'am. Yes.
Now we'll talk about formula. This was only definition. How to convert from logarithm to exponent and exponent to logarithm. Now we will move on to the actual formula parts. See, in logarithm, you'll talk about 3. First is the definition part that we did. Now we are about to move to the formula part. And the third is finding the value, that is the table. In your later on classes, when we are talking about the calculus portion, or we are talking about any entrances or any future examinations, the table part, the third part does not come. We only have this conversion, converting from log, removing the logarithm thing, and we have the formula that I'm about to teach you right now. We only need these two things in our later classes, whether you talk about calculus for 11 or for 12 or even in other entrances. We won't need the table value much, right? So what is formula? Every single formula that we have in logarithm can be derived from exponent from indices. I'll show you one or two derivation. The derivations doesn't come. But just to make you understand that how we actually get these formulas, I'll just show you one or two derivation. The rest we need to remember the formulas. So formulas of logarithm. First, if I say in exponent we had a formula, anything raised to the power 0 is
1.
1. So now if I want to convert this into logarithm, what will become? How will I write it? If I want to
Log
write this exponent part in logarithm, how will I write it?
log 0 is equals to a to the power 1.
Wrong.
Then
A goes below and the power becomes the answer. So 0 will be equal to log 1 base A.
Yes, ma'am.
Is it okay? We just did that thing. Is it okay? The base of the exponent becomes the base of the logarithm. So the base of the exponent was A, that becomes the base of the logarithm. Is it understood?
Yes, ma'am.
So
Yes,
directly
ma'am.
from the exponent indices formula, we derive a logarithmic formula. So log 1 base anything is 0. Log 1 base 2, log 1 base 3, log 1 base 5, anything gives you the answer 0. Clear?
Yes.
Yes, ma'am.
Yes, ma'am.
Now, obviously, a power 1 will be equal to a. Yes or no?
Yes.
So this a goes to the base of the logarithm. I can say that log a base a equal 1. Because if you remove the logarithm, this is what we get, right? So log 2 base 2, 1. Log 3 base 3, 1. Log 5 base 5, 1. Log 6 base 6, 1. Yes?
Yes, ma'am.
So can you tell me what would be the value of log 10?
1.
2.
1.
Why 1, why 2?
1 because the base is not specified, so we will consider it as 10.
Very good.
So when
So if nothing is written in the base, we take it to be 10. So log 10 base 10 will give us
1.
1. So log 10 for this particular chapter, the value will be 1. In calculus, what will it be? It will be log e. Because if nothing is mentioned in calculus before for the base of the logarithm, we take the base to be e. So log e base e will become 1. So in calculus, if nothing is mentioned, then log e becomes 1. In our first chapter right now, log 10 is 1. Clear?
Yes, ma'am.
yes,
Yes, ma'am. Yes,
So
ma'am.
two formulas till now. Log 1 base anything is 0. Log a base a is 1. Clear?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Third, log a plus log b. Remember, if nothing is written in the bases are 10. Okay. But even if there is something in the base, for us to apply the formula, the base of both the logarithm has to be same. Log a base c plus log b base c. The base has to be same. Only then the formula is applicable and the answer will also have the same base c. So when we apply the formula is not applicable on the base. The formula is only applicable on the upper numbers. So when we say the formula, we say log a plus log b will be log a into b, ab. It will become log ab. For example, if I say I have log 2 plus log 5, If nothing is written in the base, they have to be same. So what will it become?
Log 10.
Log 2 into 5.
Log 2 into 5, 10.
So log 10. And if nothing is written in the base, we take the base to be?
10.
10.
So the answer would be?
1.
1.
1.
If I say log x plus log y plus log z, what would be the answer?
Log x, y, z.
Log x.
X into y into z. Understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
How do we actually get this formula? See, the other two formulas we could see with the help of exponent, right? For this particular only example, I'm going to show you the derivation. We don't need the derivation for exam. I'm just showing you how we actually get this, right? Proof. If you want to write it, you can. If you don't want to, that's fine by me. So suppose I take log a base c equal x and I assume log b base c equal y. So now if I remove the logarithm, what will I get?
A equal to c power x and b equal to c power 1.
Everybody okay till here?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Let us multiply a and b. So c power x into c power y. So on
C
the
power
right hand
x.
side, same base multiply power and
Yes, ma'am.
so it will become.
C power x plus y.
Now let's convert this into logarithm. The base of the exponent will come down and become the base of the logarithm. What will I get?
Log AB base C
Very good. Answer would be
equal to
x
x
plus
plus
y.
y. Yes, ma'am.
Any doubt in this line?
No, ma'am.
No, ma'am.
No, ma'am.
So log AB base C is x plus y. What is x? Log A base C. And what is y? Log B base C. Isn't this the formula that I just wrote?
Yes, ma'am.
Right? So the first formula said log 1 base anything is 0. The second formula said log A base A is 1. So log A 2 base 2, log 3 base 3, log 10 is 1. The third formula says that if the base is same, then log A plus log B will become log AB. So log 3 plus log 4 will become log 3 plus log 4 will become
Log 12.
log
Log
12.
12.
Log 5
Log
plus
12.
log 4 will become
Log
Log
20.
20.
Log 20.
20.
Log
Understood,
20.
everybody?
Yes, ma'am.
Yes,
Yes.
ma'am.
Ma'am.
Now, the fourth formula. Every single formula can be derived the way we just did, right? Now, again, log A minus log B. Again, provided that their base is same. So here also the answer will have the same base C. So log A minus log B. Whoever has a negative sign goes to the denominator. So it will become log A by B base C. Log A by B base C. So if I tell you that I have log 20 minus log 2, what will I write?
Log 10.
Log 20 by 2 is 10. Log
Perfect.
10.
20 by
20 by
2,
2.
that is log 10. And what is log 10?
1.
1.
1 because nothing in the base, so the base is also 10. So basically, whoever has a positive sign before it gets multiplied or gets written in the numerator. Log A plus log B is log A into B. And whoever has a negative sign beside before that will go to the denominator, not to the base, only to the denominator. So log A minus log B is log A by B. So if I have, for example, log X minus log Y plus log Z minus log W, what will I write? Whoever has a positive sign will go to the numerator, and the ones that has a negative sign goes to the denominator, gets divided. So what should I get as an answer?
Log x by y into log
Log
z
x
by
by
w.
y plus
I'm sorry, I didn't understand.
Log x by y into z by w.
Okay. So x and z in the numerator, y and w in the denominator. Both in the above portion, not in the base. Clear?
Yes,
yes, ma'am.
Yes, ma'am.
Other way
Yes, ma'am.
around. For example, if I give you log a, b, c by d, and I want to expand this, how will I write it?
log a plus log b plus log c minus log d.
Very good. So whoever is in the numerator opens up as addition, and whoever is in the denominator opens up as subtraction. Everybody clear?
Yes, ma'am.
Yes, ma'am.
So four formulas. First, log 1 base anything?
0,
0. Log a base say
1,
log a plus log b provided the base is same.
log a,
Log
a,
a.
b,
Log a minus log b.
log a by b.
Clear till here?
Yes, ma'am.
Now fifth formula. Let's explain with the help of an example first. Say log 16 base 2. As soon as I see my base 2, I have a desire that I can also write 16 in terms of 2 to make them same. So I can write 16 as 2 to the power 4 base 2. So the
Yes,
number
ma'am.
that is written above, if it has a power, that power comes to the front and gets written in the front in the numerator. So this 4 will come to the front and it will become 4 log 2 base 2,
Yes, ma'am.
and that will become
4.
4 because log 2 base 2 is 1. Understood?
Yes.
If I have log 3 base 81, looking at the number 3, I can write 81 as
3 power 4.
3 to the power 4. So now when this base power will come to the front, since it is the power of the base, it will come to the front, no doubt, but it will not be written in the numerator, it will be written in the denominator. Think like this as a power 1. So 1 comes to the front, 4 comes to the front, but goes to the denominator because it is the power of the base, and it becomes log 3 base 3. That becomes 1. So the answer is 1 upon 4. If I have log 25 base 9, what can be done?
From 9 can be written as 3 square and
9 can be written
5
as
can be
3
written as
square,
5
5
square.
can be written
Then
3 square and 3 square. So,
powers come to the front.
yes,
So
ma'am.
5
So
power 2,
log
2 by
2
2
by 2
log
log,
5 base 3.
yes, ma'am, which is equal to log 5 base 3.
Very good. Everybody understood?
Yes, ma'am.
Yes, ma'am.
yes.
So basically log a base b, it will become, sorry, a power m base b power n, it will become
n by n log a to the base
n by n log a by b.
a base b. Clear?
A base. Yes, ma'am.
Everybody clear till here?
Yes, ma'am.
Yes, log.
Sixth. See, I could have done in this way also. No? How will I expand this? Suppose I have log x square y cube z to the power of 5. Expand.
From log x square
Hmm.
plus y cube minus z power 5.
log x square plus
plus
log
log
y
cube
cube
minus
minus
log
log z
z
power.
power.
So the powers come to the front. So what will I get?
Mm, 2 log x
2 log x
plus 3 log y minus 5 log z.
Very good. Everybody,
Yes.
Yes.
so can you expand log 75? Can you expand log 75? We can write 75 prime factorization
And
as,
log 5 plus log 13.
isn't it 25 into 3?
725.
5 square into 3. Can I write this?
Yes, ma'am.
Now expand.
2 log 5 plus log 3.
So multiplication log 5 square plus log 3. The power comes to the front. 2 log 5 plus log 3. You could have done it in one step, not a problem. Is it clear to everyone?
Ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
Any doubt?
No, ma'am.
No, ma'am.
Any doubt? So, sixth property. Sixth property says that log A base B can be separated as log A by log B, depending upon a certain sum that may be provided to you, right? How can it be? For example, if I say that log 2 is A and log 3 is B, then what would be the value of log 2 base 3? What will we do? Log 2, depending upon, as seeing that what has been given, we have been given the value of log 2, we have been given the value of log 3. So I can write log 2 base 3 as
Log A
Log
by
A base B.
Log A.
no. First, log 2 base 3 can be written as log 2 upon log 3. Do you agree?
Yes, ma'am.
Yes.
Now, in your
Yes.
question, entire log 2 was given the name A. So again, this log 2 entirely will become
A.
A. And similarly, the entire log 3 was given the value B. So now my denominator log 3 will become
B.
B. Did you all understand?
Yes, ma'am.
Yes.
yes, ma'am.
Yes.
Similarly, you can say another formula also, or we can deal it as a sum also. So log A base B multiplied by log B base C multiplied by log C base D. Answer.
Ma'am, is it log A base B?
Very good. So the first one, log A base B, can be written as log A by log B.
Yes, ma'am.
This will be log B by log C. This will be log C by log D. So log B gets cancelled. Log C gets cancelled. We are left with log A by log D. So this can be written as log A base D. Done?
Yes.
Yes, ma'am. Yes, ma'am.
Any doubt?
No, ma'am.
No.
Now, the same thing, log A base B can also be written in one more way. That if I take this logarithm to the denominator, the numbers swap. That means it will be 1 upon log B base A. The numbers swap themselves. For example, question. Suppose I have log AB base A plus 1 upon log AB base B. If we reciprocate them in whichever way, numerator to denominator or denominator to numerator, in both the cases the numbers swap. So now if I take log AB base A to the numerator, what will it become?
Log A to the base AB.
Similarly, the other one will become
Log B to
Log
the
B to
base
the
AB.
base AB.
perfect. Now the third property, since the base are same, the answer will also have the same base because the formula is not applicable on the base. The formula is applicable on the above number. So log A plus log B will become
Log AB
Log AB.
log AB
Log AB.
and log
is
AB
equal to
base
1.
AB will become
1.
1.
1. Understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Any doubt?
No, ma'am.
No, ma'am.
No, ma'am.
No, ma'am.
1. Log A base A is 1 ना? बेस सेम है तभी फॉर्मूला लग eighth property, eighth formula. If both the sides have log A equal log B, single logarithms, we can cancel the logarithm or you can say that we compare basically and we can conclude that A will be equal to B. A will be equal to B. Yes? For example, if I give you log x plus log y equal log x plus y, we want to find the value of x. So since you want to find x, you have to first remove logarithm. In order to remove logarithm, we have to first make them single. So on the left hand side, what will happen?
Log XY.
Log XY.
Log x
Log
plus log y can be written as log xy.
XY. Yes,
Right
ma'am.
hand side, it is log x plus y. So now we can cancel logarithm.
Yes, ma'am.
Yes, ma'am.
So xy equal x plus y.
Yes, ma'am.
Now, since I want to find the value of x, let's take into one side all the terms that consist x. So xy minus x will be equal to y. Any problem?
No, ma'am.
No,
So the
ma'am.
value of the variable that I want to find, I'll first take them to the one side. Now taking x common, y minus 1 equal y. So x will be y upon y minus. Understood?
Yes, ma'am.
Yes, ma'am.
Any doubt?
No, ma'am.
No, ma'am.
No, ma'am.
Everybody understood till here?
Yes,
Yes.
ma'am.
Yes, ma'am.
So what properties did we learn? The first one, log 1 base anything is
0.
0.
0. Log A base A,
Is equal to 1.
1. Log A plus log B,
Log AB.
Log A.
Log
log
A
A
by
minus log B,
Log A by B.
Log A.
log A base B can be written as either log A by log B, or if I take it to the denominator, it becomes log 1 upon log B base A, the number swaps. Log A square can be written as
2 log A.
2 log A.
2 log A.
yes. So using these formulas, let us try 3 plus log 10 power minus 2 base 10. Can you tell me the answer?
Ma'am, 1.
So the power comes to the front, log 10 base 10. Now log 10 base 10 becomes 1. So 3 minus 2, the answer is 1. Any doubt?
No,
No,
ma'am.
ma'am.
No,
No,
ma'am.
ma'am.
No, ma'am.
Everybody clear?
Yes,
Yes,
ma'am.
ma'am. Yes.
What will be the value of log 72 base 6 minus log 2 base 6?
Ma'am, 36.
First, log base is same, so the answer will also have the same base. Log A minus log B. So whoever has a negative power goes to the denominator. So this is log 36 base 6. Can we do something else also now?
Yes, ma'am.
What should
It's
I
at
write?
answer is to see log 6 square to the base 6.
Very good. Then
2 log 6 to the base 6, which is equal to
perfect.
2.
Very good. Everybody clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Any doubts?
No, ma'am.
No, ma'am.
Okay. Log 8 base 4 minus log 32 base 8. Right.
Ma'am, is it 5 by 2?
No, it's not. Try.
Ma'am, is it minus 1 by 3?
See, 8 can be written as 2 cube. 4 can be written as 2 square. Yes.
Yes, ma'am. Yes.
32 can be written as 2 power 5. 8 can be written as 2 power 3. All the powers come to the front. So 3 upon 2 log 2 base 2 minus 5 by 3 log 2 base 2. Agree?
Yes, ma'am.
Yes.
Yes.
Log 2 base 2 is 1. So we are left with 3 by 2 minus 5 by 3. We can take the LCM 6. 9 minus 10. So minus 1 upon 6. Is it okay?
Yes, ma'am.
Ma'am.
Okay, question. Express as a single log, as a single logarithm. 2 plus half log 9 base 10, log 9 base 10 minus 2 log 5 base 10. So what we want is to concise them into a single logarithm. Rest is fine, but we have a number too. So the first challenge that we have is how can I write 2 in terms of a logarithm? How can we write 2 in terms of logarithm? See, 2 can be viewed as 2 into 1.
Yes, ma'am.
And everyone has a base 10. So I can write that 1 as log 10 base 10. Do you agree?
Yes, ma'am.
Yes? So
Yes.
now here, this half entirely goes to the power. Do you agree? Because the numbers come to the front only, right? I don't want to change the base. So I'm not sending 2 to the base. I'll send this entire half to the power of the upper number. Do you agree? 9 power half base 10 minus 2 goes to the power 5 power 2 base 10. Is it okay?
Yes, ma'am.
This 2 also goes to the power 10 square. 9 can be written as 3 square. This is 25. So whoever has a plus sign gets multiplied. Whoever has a negative sign gets divided. So log 100 into 3 divided by 25 base 10.
Yes, ma'am.
25 fours up. So this become log 12 base 10. Any problem?
No, ma'am.
Guys, any problem?
No, ma'am.
No.
No, ma'am.
That's it for today's session then. We'll continue in our next session.